welcome back. It's actually 2017 now. Last night was New Year's Eve, so this is the first day of the new year. So we're going to continue on with our projects. We finished up the first bracket. Some of you have already seen the video. The first bracket for the Wilton. So we're going to be moving on to the second one right now. So these are the two brackets that we finished up. They came out, pretty decent. There's a couple things we're going to change on them. If we make them again, or if someone wants to buy some for their Wilton or something like that. We don't need the screw holes if we do it differently out of a block, but for what we're doing, these came out really nice. The hash marks for the angles, they're on there, but like I said, we might end up actually putting a plate over there that actually has laser marked degrees on there. Typically when we set up the sander, we usually use a protractor anyways to get real accurate angles, so it really more for aesthetics and that they were there, so we figured we'd put them back on. So we're going to go on to the second bracket now, and this one's again a little more complicated, only from the standpoint that it does have this pretty pronounced internal V here. So I've been thinking about it a little bit of how I want to do that. I'm not saying it's the best way to do it. I think it's just the way that we're going to do it. Initially, I was going to use the lathe. I was going to put the blanks of this on a face plate, and then go in with either a ground tool or just a finishing bit like this. And you can see that this if I set the compound up or even programmed on the CNC, we probably could have gotten what we wanted out of this. It's aluminum that we're cutting, so the interrupted cut really doesn't bother me if we did it this way. It actually matches the angle very nicely. So again, maybe if we make them again, we'll try a different method. But I think for what we're going to do for the ones that we make for our sander here, I think I'm just going to take, and I know you're going to think this is crazy, I'm just going to take this small 3/32 ball end mill, and I'm going to go down, clean a lot of this out with just the standard flat end mill, and do some pocketing and things like that to remove a lot of the material. And then I'm just going to go in with this ball end mill, and I'm just going to 3D mill this angle here all the way down. You can see that the end mill doesn't quite go all the way, if I stand it up straight, all the way down to the crest of this piece. But when you actually put the mating piece in there, it doesn't go down to the crest anyway, so that's not going to be a big deal, and it'll be a radius on the bottom. And the only reason I'm doing it that way is if I 3D mill this surface with a ball end mill, I'll make the step overs pretty coarse, so I'll get a pretty rough surface finish on this particular surface here, and I think it'll help bite into this piece on this surface right here that it's going to be locking up against when we tighten these down. We'll see how that works. If I did it on the lathe, I'd have a real nice surface finish on there. I'm not really sure that's what I'm looking for, at least at this point. I don't know if that's what I'm looking for, but we'll try it and see how it works out. If we have to make them again and do it differently, that's no big deal. So I mean, some of the other features on here, this pilot hole for locating it on the Wilton, a couple of locating pins that we have to put in. This piece actually is broken off in a couple places, not just in half. So this one really got the crap kicked out of it. But so we got this set up here on the fixture plate. So we're gonna start reverse engineering this, get some ferrule measurements off of it, and then I'll take it from there. So I already calibrated the ferrule arm, so we'll do a little bit of adjustment here, and then we'll get this going. Okay guys, so there's the piece. Pilot holes. So basically, we have these locating pins in ours. I just digitized these pins to get those hole locations and sizes. These are just spring pins, so we'll size these holes based on a spring pin spec. 247. This is a 1/4 inch pin. So, we'll size it accordingly. Again, even with this pilot, we'll go out there and measure the Wilton itself, measure the mic out the pilot that goes through here, make sure we get a nice clearance fit there. So, and then on the side here, you'll see that, we took this right down to a point here on this angle. This angle came out to about 30 degrees. I changed it to 29 degrees because I do want a little bit of interference with this angle and the mating piece. I might change it to 29.5. Again, we're going to have a rough surface in here as well, but so that's why this one goes down a lot further, because it actually has or not as far I should say, because it has a radius there. So if I radius this right now, this would come up to here and it would look more like this. But the distance of this flat here is about 203 if I measure it with the verniers. Up here it's about 204, so that's right within what it needs to be. So that's pretty much the part. And again, we're for this surface in here, this whole surface, we're gonna go in there and we're just gonna 3D mill all of this to get the feature that we want. We'll see how that works out. If it doesn't work out the way we want, then we'll change it to a different method. Maybe we'll turn it. And then all these corners here, we're just gonna, when the end mill goes around and does its contouring, it's gonna put corner radiuses in there. I don't typically put corner radiuses on my models if I don't have to. I just let the end mill give me what, if I go around with a 1/2 inch end mill, I'm going to get a 1/4 inch corner radius. And again, for parts that we're doing in the shop here, that's fine. That works well. So we're going to get this part programmed up, and then we will get it back on the Haas probably, because of the 3D milling that we're going to do here, and the Haas, just because it has more memory, it's a lot easier to deal with it on the Haas, and plus the spindle speed I can take up to like 5,000 RPM, so that'll give us a nice quick tool path through there. So let me get this programmed up, and then we'll look at the program, and then we will go from there. Hey guys, welcome back. We're finishing up the second portion of the clamp piece here for the Wilton. So I'm just going to show you where we're at right now from the model and the programming, show you what I changed from the last video. So basically, this is the piece again that we're working on, the cast piece, and the tricky part for this was getting this little cut in here. Originally I was going to go in there with a 3/32 ball end mill and 3D mill this profile into it. I changed that a little bit. I'm still going to mill it, but I'm going to use an 1/8 inch end mill, and I'll show you on Mastercam real quick what we're going to do. The reason for that is I do want a little bit of relief in the bottom section here, so when we actually clamp the receiving piece on there, we don't have any interference, and you'll see more clearly in the program once I show that. This is my little sanity check here. Like I told you, I do on most of my 3D or my reverse engineered stuff, if it can fit on a piece of paper, and I'm not going to be able to get that lined up, but you could see if I could get it lined up that it actually matches pretty well. So we know our geometry is pretty much what we need it to be. So what we're going to do now is I'm just going to show you the program, and then we're going to go back on the Haas and get this thing set up and running. So let me show you where we're at right now. So again, this is the model here. This is what, based off the 3D digitizing and the scanning, well, not the scanning, but the 3D digitizing, this is what we came up with. I did lie a little bit. I did actually put my corner radiuses in here. I was just going to let the end mill produce those, but because I wanted a nice clean transition in there, I did make them something like a 260, 265, so when my 1/2 inch end mill goes in there, it actually moves through that and actually doesn't stop in the corner and shatter. So that's why I did add the radiuses. So this is the model here, and then over here, this is the program. This is the Mastercam program with all the tool paths. And you can see that, maybe you can see, these tool paths down through here, which are hard to discern what they're actually doing, but that's actually picking up this surface in here. And getting down to this sharp corner here isn't going to be realistic for the way we're doing it on the mill. So when you actually run the program, This is actually what you're going to end up seeing over here on this screen. So this is basically the cut surface. You can see my step downs are about 30 thousandths, so they're a little coarse there, and that's what we wanted. So we had a little bit of surface finish there to grab onto. And then this is that undercut I'm talking about right here. So basically I do have a path coming in here with a ball end mill that comes down and actually relieves this surface here. So when the mating piece comes up, and if it works past this at all, there won't be any interference. Based on the model and the parts that we have, it should come past this surface here about 20 thou, and that's about it. So we are using the majority of this surface here. But that's what it's going to look like. So you can see here's the ball end mill relief, and it's different than the actual sharp transition that we're showing over here. So let's go back to the mill, get it set up, and then we'll get this thing, get it running. Okay guys, so we're at the Haas machine here, and so I just found a block of material. It's just a scrap piece of material that was from another project. It's already fly cut on the top from when we were setting up whatever other piece came out of this. So this will actually fit our piece nicely. I can actually get two pieces out of this if I do it right. So what I did was I just laid this piece on the block here, and I just made a little, I know when I programmed my part, I put a bounding box in my program around the actual size of my part, and then I called the corner of that block my zero. So basically I'm just laying this in kind of in its position here that it fits within this block, and then I'm just going to come down with my center drill, get close to that, and then just zero the program and the machine out there. Because again, the nice part about pulling it out of blocks and not have to worry about indicating and finding all these different centers, as long as my part's is within my envelope of raw stock size here, we'll be able to fit it in just fine. So that's all I'm doing here. So there's a couple blue marks here that are kind of crisscrossed, which is the bottom limit of my piece, and then the side limit of my piece. So I'm just going to come down with the center drill, get it close to that blue mark there, and then we're going to zero it out there, and I'm going to come out, touch off the top of my block. When I programmed this, I was basing it on a 1-inch piece of stock, and the program's already in the machine, and the offsets for the tools have already been set. So if I go to the actual program Z position, I'm actually going to hit my vice jaw here by about 5 thousandths of an inch, because there's already material off of this original piece of 1-inch stock. So what I'm going to do is when I come down and touch off my probe, I'm just going to put a 10,000 shim over the probe, and that way it'll actually shift all my tools up 10 thousandths of an inch, which is fine for the size of this. This has to be like 850 overall, and there's nothing critical about it. I mean, if we go thinner, it doesn't drive any of the features on the Wilton sander itself. It's not as if it's not going to work. So I just want to make sure I don't hit my vise, and we're going to get close to it. And I've got real thin parallels in here right now that are pretty much giving me as much clamping I can get on this particular piece of material. So I'm just going to zero this out right now, and then get my X and Y position, bring the tool probe down, probe it, and then we're going to start cutting this. So I'm going to call that zero there. It's close enough for government work. So we'll just zero everything out there and get the Z in there and get this thing going. Okay, it's my Z position, X and Y are done, so now we can run the program. a quick change here. When I programmed it assuming I was going to use one little block of material, and it was going to be situated with X on the front surface of this curve here, and then Y along the side. But now that I'm going to be doing it out of a block with this orientation, I had to go rotate my axes so that the orientation of the part was flipped 90 degrees, so I can actually run it and get two pieces out of this one block here. So let's try that again and see how that looks. Okay guys, so there's the first piece. You're not going to be able to see it that well until I get it out. So what I'm going to do is, oops, a little aggressive there. You can see the cut a little bit here, but with the reflection of the aluminum and all that, it's hard to really tell what's going on. But what I'm going to do now is I'm just going to slide. I'm going to put some more indicating marks on the block, similar to what I did in the last piece. And I'm going to put the new piece, change my offsets in the machine, slide everything down so I can actually get another piece on here before I take this block out of here. That way I'll have two pieces in this block. And it's already indicated in. I know that my tools didn't touch my vise at all, so that's good. very, very close, but that's okay. Close is okay, touching is no good. So I'm just going to change my X and Y zero position, keep the Z the same, and then run another piece since all the tools are already set up. And then what I'll do is we'll take this out of the vise, get it over to the bandsaw, and we'll rough cut these out, flip them over, fly cut them to size, and then we'll have these two pieces to look at. So that's all I'm going to do now. I'm just going to shift my origin and then run another piece. Alright guys, so there they are. Not sure they're going to work yet, but they look good though. So yeah, so like I said, I got two of them out of one block here. Just shifted it over and ran the second piece. So you can see the angle in there. We'll get a little better look at that once we get them out of the machine. I'm going to get them over to the bandsaw right now. We'll get them rough cut out, then we'll bring them back over here, fly cut them, get them to the height that we need, the thickness, and then we'll take them out to the lab and compare them against the other pieces and see how they work. If not, we'll make some adjustments and then we'll find another piece of scrap material and run them again. Okay guys, so we're back at the Haas here, so now I'm going to fly cut the back side of these off just to get rid of this rough material. The way I'm going to do that is I'm just going to put a V block in my vise right here to pick up the back side, to pick up this diameter right here, just so I get a better bite on it. It's hard to see it, but if I did it this way, that way I get a better bite on that diameter, and then I'm just going to grab the two crests of this arc here in the moving jaw, keep this V block on the fixed jaw, and then we'll just fly cut it. I'm not going to take real big cuts. I don't want it to come out. So that should hold it pretty good. We'll see how it does. Oh, and also I have a parallel down here too that this machine surface right here will sit on. That way at least I know I have something that's keeping my parallelism in there. So let's see how it works. So there's one of them. I'm just going to fly cut the other one, and we'll go into the lab and see how they work. Alright, we'll be back. Alright guys, so there they are. The fours, and then the afters. We'll take a closer look at these, but they came out pretty good. Definitely better than what was on there. You can see this one actually cracked into more pieces as we were working with it. So they're definitely going to have to be replaced one way or another. So there's both sets of them. So I'm just going to pull them a little closer to the camera. We'll take a look at them. A couple things well, at least one thing I know off the get-go I'm going to change on them. On the slider block here, and I'll show you what that is in a second. But let me just readjust the camera here, and then we'll take a better look at these. Hey guys, welcome back. So we're going to take a little closer look at these brackets. For the most part, they came out really nice. Nothing really major I would change on them if I made them again. There's a couple little things I'd probably modify just to make the robustness of them a little more enticing. And that's really just how the slider mechanism works. And I'll show you what I mean. So here's a close-up of the brackets. And again, I mean, I think they came out really nice. The features, all the things that were supposed to be functional on them are functional. The piece itself, the slider, which was the more difficult one, the angle actually came out really nice on this. And the fit to the actual slider itself actually works really nice. The only thing I would change, and you can probably see it here in this location right here, is the space between the bottom of the slider and the actual arc right here gets really close to the bottom of that ball end mill cut that I put in there. And what you don't want to happen is you don't want the base, let me slide it out here a little bit, you don't want the base of this, find a good orientation to show you, we'll get it. So what you don't want is the base of this right here bottoming out on the face of this. The whole idea is that this angle here on the actual, boy, I'm having a problem with this camera today. You want this angle here to push up on this angle here and actually drive these two diameters up top here together. So as this moves in, picks up that angle, it pushes on the top surface here, and then let's see if I can show it. It's hard to see, but you can kind of better see it there. It's supposed to push, the angles should push these two diameters together, and what it does is then creates a nice lock. So the wedging action of the actual angle itself should push the two diameters together and actually make them lock. What I did was, in order to clean up this one face in here, I actually made the tool cut about 5 to 15 or 10 to 15 thousandths undersized. So it actually took more material out of here so I could have a nice diametral fit on this sliding piece. And I got exactly what I asked for. Fits really nice, there's no play in there, but I get very little camming action from the actual angle pushing up and locking in place. The angles themselves still touch, and it doesn't bottom out at the bottom there, so I still am getting some locking. But I think what I would do if I did it again is I'd actually leave the material on this interface in here and let it be a much tighter fit in there. And what it would do is actually move this piece and have it engage much further out. So as I pull them together, as the nut pushes on the back side of this piece and pulls them together, it would actually slide up that ramp and push it real tight up against that diameter. But other than that, one minor little change. Everything else came out good. I do have to put the spring pins in here yet, so I'm going to press them out of the broken pieces. We need these for guiding. So I'm going to do that now, and then we'll go back to the sander and we'll put these on and see how they actually lock and see how they actually locate, see if everything else lines up. So I'm going to head back there, push those pins out, and then I'll meet you guys at the sander. Well, there they are, guys. They actually fit pretty good. Let me see if I can loosen one of these and I can show you how it rotates without killing myself here. So that's loosened up now. So you can see they slide through there very nicely. Just a little bit more. So there we go. If you can see that good or not, I'm kind of close, but so there's the table moving up and down. And then once you get them where you want them, I'm trying to use one hand, just tighten one down, get my hand out of the way. So actually they came out really good. Here's the other one. Tighten that one up. Yep. A lot better than the cast ones. So I think that'll work. I think that's a project done. So that's it. Now we can move on to some other projects. Not sure what the next one is yet, but I got a bunch lined up. But that's the brackets. So if anyone has any questions, concerns, comments, please add them to the YouTube page and we will continue on. Cheers.